How's it going, everybody? I'm John, projectfullstack.com. You can check out the website right there, but be warned, it's super basic. I put all of 5 minutes worth of effort into it. That's not true. Maybe it was like 10 minutes. But in this tutorial slash series of videos here, we're going to talk about object-oriented programming in Python. I don't know how many videos are going to be in this because I'm literally recording the videos as I go. This is the first one, so I don't know how many videos it's going to take by the time I'm done. But without further ado, let's go. This first video is probably a little boring because it's, slideshows and talking. Next ones we'll actually get into, running some, getting on the keyboard and getting some miles on the keyboard and actually coding. And that's where you really learn to program, is when you actually get on the keyboard and code. Some requirements for this: basic Python programming, okay? I'm not going to teach you how to program in Python at the basic level. If you don't know what a variable is, or control flows such as loops or if statements, conditionals, function definitions, if you don't know what those are, this class isn't for you. Maybe by the time you watch this, if it's in a month or two from now, I'll have a basic programming class on my channel here. But as of right now, I don't. But this isn't for you because I'm not going to go that basic into it. However, if you're rusty at Python, but you do understand variables and loops and if statements and all that, that's perfect. You'll do just fine. You're also going to need some type of basic text editor or an IDE, integrated development environment. I'll be using PyCharm. It's easy. It's super powerful. It allows me to debug and break at specific lines so we can evaluate the state of our programs at specific points. So it's super good for that. If, let's see, it's free for students. If you're not a student, it's pretty expensive. So I would recommend Visual Studio Code. It's really good as well. And then obviously you'll need Python installed. But again, this is a base. I'm not going into basic Python programming. So I'm just going to go ahead assuming you have Python already installed. If you really want to be a Patreon, you can go there. It doesn't really matter. You don't get anything special out of it. It's just an extra way to say thank you to me if you gain any amount of value out of this video. But don't worry. You don't feel obligated to do it at all. You don't gain anything out of it. All right, so object-oriented programming. Anytime I hear like buzzwords in programming or any technical field, I always like to try to break it down in normal English first. So what is an object? An object is a material thing that can be seen and touched, or it's a person or thing to which a specified action or feeling is directed. All right, just sitting here in front of me on my computer, there's multiple objects. I have a keyboard. I can see it, I can touch it, I can interact with it. I have a coffee cup. I can see it, I can touch it, I can interact with it. So I have objects all surrounding me. But what is an object in programming? An object in programming, or in computer science, it can be a variable, a data structure, a function, a method, etc. But it is a value in memory referenced by an identifier. So when you're thinking about objects, I want you to think about memory and state. What is the state of the object? And we're going to get more in detail in this in the future. So here's my example here where I basically have two objects sitting on my desk. I have two coffee cups. They're both roughly the same, right? They're both the same color. They both have a little handle. They both have some amount of coffee inside of them. I can interact with them completely independently. No matter what I do over here with cup 1, it does not affect cup 2. I can pick up the leftmost cup and drink coffee out of it, set it back down. It doesn't affect the amount of coffee in the cup on the right here. I could take the cup on the left here, pick it up, smash it against the wall, throw all the pieces away in a dumpster, and I would still have the rightmost cup over here completely unaffected. Okay, so that's a big thing to remember, is the concept of objects are completely separate instances in memory from each other. Interacting with an object A does not affect object B unless they're specifically programmed to interact with each other, to affect each other. Let's see, when I talk about the state, if you're not familiar with that term, all the state means it's just basically the sum of all the properties we have, like all our variable names and whatnot, and the values that are associated with them. So I can change the state of this cup on the left. I can drink half the the contents of it, and I can affect the state of that, whereas the state of the cup on the right is completely unaffected. It still has a property, being the number of, like the ounces of coffee left in the cup. However, I can alter the state of the cup on the left without altering the state of the cup on the right. So think about objects, they're things in memory. They each have their own specific state, and interacting with an object does not affect the state of the other object unless they're specifically programmed to do that. Alright, so now we kind of know what an object is. Something in memory that has state. So what is object-oriented programming? It's a paradigm. You see it normally abbreviated OOP here, object-oriented programming. It's a programming paradigm. Paradigm's a fancy word for model, or kind of like a way of doing things. So it's basically a technique of programming that's based on the concept of objects. Objects can contain data and code. Data in the form of fields, right? Attributes or properties. In our coffee cup example, a data could be the number of ounces in the coffee cup. Or code in the form of procedures, also known as methods. So maybe I have a coffee cup object. It's got the property, how many ounces in it, and it's got some type of code to either drink and remove some of those ounces, or some type of code to add some more coffee. Objects have their own procedures that can access and often modify the data fields of the object. It's kind of what I just said when I said it has the ability, if we had a procedure in my coffee cup, a procedure to refill it, or a procedure to drink from it. We have a procedure that is accessing and modifying the data fields of the object, the number of ounces of coffee in that object. So in object-oriented programming, we basically make classes which are the blueprint, from which we create instances, which are the individual objects. So I could have a cup class, and then I would have two completely separate objects, the left cup and the right cup. So what is a class versus an object? We kind of talked about it, the blueprint versus the object. And this is normally confusing for people until they actually start getting on the keyboard and coding. So I don't want to get too much into kind of the academic side of things here, because it's going to be a lot more apparent once we start coding. But here's a good little definition from Wikipedia. In object-oriented programming, a class is an extensible program code template. Template, basically a synonym for blueprint, for creating objects which provide the initial values for state, such as all those variables, and implementations of behavior, which are your functions and methods. So the class is the blueprint, and the objects are the specific instances of that class. You can have as many objects of a single class as you want. Interacting with any of those does not alter any of the other states of the specific objects. So here's how you create a class in Python. You use the Python keyword class, followed by a space, followed by a specific name for class. Standard convention is to use camel case, which is no spaces between your words, and the first letter of each word is capitalized. So that's why the M is capitalized in my, and the C is capitalized in class. That's kind of known as camel case. Standard Python convention, but it's not required by the syntax of the language. And the colon. And then, just like every other statement in Python that needs a colon, you need all sorts of indentations underneath it. Everything that belongs inside of this class is going to be indented underneath it. So to use an object, or create an object, I should say, you use class instantiation. It's a hard word to say, at least for me. All right? So we create a new instance of the class, or an object. We use function notation. And all that really is basically like pretending it's a function. And then you can pass 0 parameters into the function. In my example, in a minute, we're actually going to pass something in. So yes, you can pass things in here as well. But it's the name of the class followed by parentheses and followed by whatever you want to pass into the class when it's created. To use an object, we'll talk about dot notation, the dot operator. Okay. All that's really saying is you need the name of the name of the object. So again, up here, let me go up one slide. We created an object called X. So now I'm saying, hey, get that object X. Go into it and get the F function. And I'm going to back up a couple slides because the F function is defined right here inside of our class when we create it. So I created an object of this class. I'm saying go into that object state and run the F function. Okay? Go into what's in the left, get what's in the right. Anytime you see a dot, just think about that. Go into what's in the left, get what's on the right. Here's an example where I created a class called dog. It's got a scientific name. It's got, this is a property, right? It's a variable name that's indented underneath a class, so it's a property of that class. It's got a init. Notice the double underscores, underscore, underscore, init, underscore, underscore. That's a constructor method. It's a special method that will run every single time you create a new object of this class. And what you do with these is you just basically use this function to set the initial state of the object. So all I'm saying is, hey, when I create a dog object, when I create an object of the dog class, I'm going to tell you what the name is. And when this runs, it's going to say self. Self it's a very special thing, also kind of referred to as this in some other programming languages. It's always going to refer to the object that called this method. So it's basically going to say, hey, take that newly created object and set its name property. Create a property called name and set it equal to what I passed in here, the name I pass in. We'll see this in a second. And then it's got this function bark. It still needs this self parameter, but I'm not using it. It's a very simple method here that just basically returns a string, just as a very simple example. So this is how you use a dog object. Real Python example created using dog objects. So I have two separate objects I'm creating. Notice I have two variables, dog object 1, dog object 2. For dog object 1, I'm creating an instance of the new class. So notice I use the class name followed by parentheses. And inside of that parenthesis, I'm passing a string. That string, Basil here, and for dog object 2, Bronson here, is going to be passed to the constructor. So when you create an object, it runs the constructor here. I don't pass in the self parameter because it's implicit. We just pretend like we don't need it. We don't use it when we're calling it. But I am passing in the value for name. So this constructor is going to run, and it's going to say on that object that we just created, the self, set the name property equal to whatever we pass in. In this case, it was Basil. So for that dog object 1, it's going to create a new object. On that state for that object, it's going to create a property called name, and it's going to set it to Basil. Now, when I create dog object 2, it's going to do the same thing. It's running the same exact constructor, right? But now self is pointing to dog object 2. So now when I run the init, the self points to the object I'm creating, which is dog object 2. So I'm saying take dog object 2, set its name property equal to what I passed in, which is Bronson. And then I use the dot notation to interact with them. So let's actually see this in Python before we end this video. Here's my dog class. It's got a property scientific name. Here's my constructor, the double underscore. Self, which again, we never actually pass in, but it will point to whatever object we created. So we use the self parameter to reference that. And we're saying whenever you create a dog, you have to give me a name. So it's an input to the constructor. This constructor runs every time we create a new object. Then we just have this random bark method. Doesn't really do anything. We still have the self parameter. But again, I'm not going to pass in self when I call it. You can notice down here when I call bark, I don't pass anything in. Because remember, self always points to the object that was either created or the object you're interacting with. All right, so I'm going to run this. I'll run it without debugging first. And we'll just see what's printed out to the screen. Okay, So here's line 36, dog object 1.name, which prints out Basil. Because remember, when we created dog object 1, we said run the constructor for the dog class. I'm going to pass in Basil. We're going to go up here. This constructor is going to run. It's got Basil here for the name. The self points to the object that was just created. The name property on that object is going to be assigned the value of whatever we passed in for this name parameter, which is Basil. Then we're going to come down here and bark, 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 right? So that's this, line 37, bark, bark, bark. So dot notation, go into the dog object 1, give me what's on the right, the bark. And because I created that dog object from this class, it has access to all the properties, self.name, scientific name, and all methods, bark, of that class. And then dog object 2, we do the same thing. I got, and that's down here. Line 40 is what's highlighted there. That prints out Bronson's name. Notice I'm referencing the same exact property, right? The name property, but I'm using a different object. So I'm saying get the name property of dog object 2, which when we created it, we set it to Bronson using the constructor. And one last thing before I end this video is I'm going to run the debugger here, which is one of the main reasons I love PyCharm. This may be a little hard to see. I'll have to see in the future if I can increase this font size. But notice what this does is it breaks right here. It's stopping my program from running right here on line 36. It's basically paused my program and it's telling me the state of my program at this given time. And you'll notice my state is I have two dog objects, dog object 1, dog object 2, because I created them above that breakpoint. Each dog object has the name Basil for dog object 1 and the scientific name Canis lupus familiaris, whatever that is, for dog object 1. Dog object 2 has the same properties, which makes sense because it's created from the same class, so it's going to have the same properties and the same methods. But it may have different values. So we have two specific objects that exist in memory, and each one of these objects has its own specific state. I can interact with dog object 1 and alter its state. I can change the name or do whatever I want without altering the state of dog object 2, because you can look at the little memory address right here, and they have completely separate memory addresses, which makes sense because we said the objects are basically pointers, references in memory, and they reference two separate, completely separate spots in memory. So if I interact with the spot in memory over here, I'm not going to alter the spot in memory over there. So hopefully that's a quick little primer. Object-oriented programming, the concept of classes and objects is one of the most confusing things to learn in programming, I think personally. Other than maybe recursion. I think recursion is a little difficult to understand, especially the first time you do it. But so this is just a little primer we're going to get into, and we're going to break down and play around with the constructor and see what it does and what it doesn't do. We'll do all sorts of different methods. Eventually we're going to create classes off of other classes. So I'll create new classes that subclass this. So I'll have like, a Chihuahua class that says, hey, it's of the dog class, but we're going to add a new property or change the property of scientific name. And by the end of all this, you should be pretty familiar and be able to work pretty confidently within an object-oriented environment in Python. So hopefully you got something out of this video. If you did, go ahead and like, subscribe, leave me a comment, say good job, or tell me what I did wrong and what you want me to improve. So, all right, thanks.